If you're like me, you've got a ton of programming side project ideas that you want to build, and in the age of AI-assisted programming, it's easier than ever to actually get them all built. But when it comes time to deploy, the options are still not great. Platforms as a service like Render, Vercel, Heroku, Railway, Fly.io, etc. can make deployment simple, but for me, the price and performance is not quite there. Let me show you what I mean. Here we have the pricing on one popular platform as a service called Render, and I find this pricing to be pretty comparable across the other platforms, like you would find pretty similar pricing at, say, Heroku. Let's consider we're building a web service. We are looking at the compute pricing here, and if we look at the services tab, this is going to show us the cost of running a compute process for a web server. And as we can see here, there is a free option, which is obviously just for development. That's 0.1 virtual CPUs. It's free, 512 megs of RAM, pretty low. There's a starter for $7 a month. Again, that's half of a virtual CPU, which I assume would not be enough for production. So we're really looking at the bottom tier here being the $25 per month level. That gives you 2 gigs of RAM and one whole virtual CPU. So that is one compute process running the web server. If we look at a database, here is Postgres, which is what I use and I think is a pretty popular option. If we look, there's a free option. It's obviously just for testing. There's a 30-day limit, and then they're going to cut you off. 0.1 virtual CPU, definitely not enough to run a real database in production. Same thing with the 0.5 at $19 a month. So really the minimum viable numbers that you're looking at here is either the $75 a month for a basic 4 gig process, or the $55 a month, probably the better option because you get some of these other extras like the point-in-time recovery and whatnot. But anyway, you're looking at $55 a month and $25 a month, so that's $80 per month at a bare minimum. And that is just if you're running one web service. If you're running multiple web service processes to handle more load, or if you're running a background worker process, say you're processing background jobs from Redis, you are going to be paying another 25, maybe another 7 for a Redis background worker. But in any case, you're looking at a bare minimum of $80 a month. And if you're building out multiple side projects, if you have, half a dozen of these things, that's another $25 a crack. I'm not familiar with Render's hosted Postgres, if they can all share the same instance of Postgres or not. But suffice to say, I think $25 a month for a single virtual CPU, 2 gigs of RAM, for me anyway, is pretty high. And that's not getting into all the other services that are metered. You're paying a quarter for a gigabyte of storage per month. I assume you're probably going to pay for bandwidth egress. A lot of these services charge you for that. So, and also my experience on these is that they say they're giving you one virtual CPU. When I actually run that in production, it is really sluggish. And then also some services have cold starts. They'll freeze your apps if they haven't been running for a while. And then the first request that comes in will get woken up. That can be a pain too. So for me, the performance is kind of low and somewhat unpredictable, and you are paying a premium for that experience. So instead, for the types of apps that I run, I find it a lot more cost effective to run a dedicated server, which is a managed actual physical server in a database, and I'm fully in control of the software. I get my own CPU, my own RAM, the hard drives. That all belongs just to me. I don't have to worry about any other processes, noisy neighbors or anything. Sharing the same CPU, RAM, and storage as me. These are actual NVMe hard drives on my own server. These aren't block devices with unpredictable storage latency and input-output operations per second. So basically, what I would like to do is walk through the whole process of getting a dedicated server from OVH. And I'm going to show you how to set it up from scratch, install Proxmox, do a little tweaking of Proxmox, and we are going to set up Redis and Postgres virtual machines, and we are going to set up a Kubernetes cluster using K3s, which is a lightweight Kubernetes distribution. And we are going to deploy a little demo app to the cluster. And we are also going to use Ansible to do a lot of this work, so that makes our work reproducible. In the event we need to quickly spin up more resources, we can just edit our playbooks. Or if we need to rerun them later, it's all idempotent. We can just rerun it as many times as we need to. And then finally, we're also going to install Tailscale on every VM. And that is going to make it so that we can SSH into our VMs without needing to expose them to the public internet and all the security implications of that. But before we actually get into doing that, I thought we would talk a little bit about the trade-offs of going this route. What are the benefits and drawbacks to using a dedicated server compared to the platform as a service or the cloud providers that we talked about? Well, the first thing we've already talked about a little bit is price. On every platform as a service and cloud platform, the cost can be pretty variable and sometimes surprising. Vercel is notorious on Twitter or X of people posting surprise high bills, and that can happen if you suddenly have a spike in bandwidth or a spike in storage usage. You'll suddenly get a surprise bill that you had no idea you were racking up. Whereas with the dedicated server, you get exactly the hardware you pay for. You get whatever RAM, CPU, storage, and you typically get a guaranteed amount of internet transit. In the case of my server, it's a guaranteed gigabit per second. The next consideration is performance. On a platform as a service, compute processes for running web servers or background jobs are often just a single shared virtual CPU, sometimes a fractional virtual CPU, maybe a couple virtual CPUs. I often find these worker processes to be sluggish. I think they're typically oversubscribed on some of these services, so you're probably getting less than a real virtual CPU, or at least you could be subject to noisy neighbors using up more slices of your CPU than is fair to you. Databases are often sluggish with storage limitations, and on cloud platforms like AWS, you have to pay quite a bit to get your input-output operations per second up if you're using block storage devices. Meanwhile, on a dedicated server, I get the full resource utilization of all the hardware I pay for. I get my own CPU's memory and storage, no worries about noisy neighbors. And for web apps, I don't need to worry about the distance between wherever my code is running and wherever my database is running. If they're in the same data center or different data centers, they're running on the exact same machine. So it's about as low as you can go without the web server literally running the database process like a SQLite. The other aspect that's nice about dedicated servers are there's a lot of freedom to run custom workloads. I do some GIS work, so I like to run H3 and Postgres extensions, and sometimes I might want to run some other Postgres extension. I'm able to just log in as a super user and install whatever extension I want. But if I was running on a managed Postgres, such as Amazon RDS or some of the other managed Postgres services, typically there's a pre-approved whitelist of Postgres extensions, and if your extension that you want isn't on there, you're kind of out of luck. I also have the freedom to run other niche services, like if I wanted to run a Vespa search service or a analytics database like ClickHouse, it's really easy to spin up additional VMs on my server, and I know exactly how to connect to my existing services. When I'm running in a platform as a service or on the cloud, I can still do that, of course. I can buy virtual machines like Amazon ECS, but sometimes I need to try to guess where my code is actually running on a platform as a service. These platforms don't always tell you that they're running your code in Amazon data center or a Google data center, so it can be a little bit of a pickle trying to figure out where to deploy a database on that's going to get as physically proximate to where your code is running as possible. So those are some benefits to running on a dedicated server. There's also downsides to consider. We already talked about price, but the downside of buying a dedicated server is that you are paying a flat monthly fee. And if you aren't making good use of the hardware that you're paying for, then you're kind of wasting money. And it is possible on some of the cloud platforms to get a really low monthly bill. Like I've written AWS Lambda apps that just cost pennies or less than $1 a month to run because they're not doing a whole lot. They're low resource utilization. And that's certainly possible. But of course, like we talked about, the downside is that if you hit that elastic demand, your bill could spike up to a couple orders of magnitude above that. Performance-wise, on a dedicated server, we talked about the benefits you get, but there is a ceiling as well. You only get as many CPUs and RAM as you have, only as much storage as you have. If you approach or hit that limit, you either need to buy additional dedicated servers and set up some type of clustering setup, or you need to migrate to a larger dedicated server, and that's going to require planning, possible downtime, whereas some of the platforms as a service and the cloud providers, by having everything virtualized, they can move workloads around a lot more seamlessly, the trade-off being the higher cost. For me, the apps that I run have a pretty predictable workload, and they benefit from a higher baseline performance headroom, so I don't really need to worry about that, but it's something to consider. The other thing is we talked about the freedom of running whatever we want on our dedicated server, but that freedom also comes with a lot of responsibility. If our database goes down, nobody's going to tell us. Nobody's going to come running to fix it like it's a managed service. So we need to handle alerting and we need to handle fixes ourselves. And we also don't get a little push button to enable backups like some of these services have. We have to code up and deploy our own backup solution using pgBackRest, WalG, Barman, or other tools like that. That said, I don't think running Postgres is really that hard. I know a lot of people get scared about running their own services, but it's really not that big of a deal. The same thing with running a K3s cluster. People get scared about running Kubernetes clusters, but if you use a lightweight distribution like K3s, it's really not too bad. And when it comes to the backup situation, you should be testing your backups anyway, so it's not a whole lot more work to just implement the backup solution regardless. One more consideration is the availability or the downtime/uptime of your dedicated server. Because we're running on bare metal, if something catastrophic happens with our hardware, a CPU fails, RAM fails, our data center provider, like OVH, is going to page a data center worker to come fix it, but our server is going to be down in the meantime while that's happening. So we are going to suffer some downtime if that's our only server. We can minimize this risk by continuously backing up our data, and if there is a likelihood of extended downtime, we could stand up a new server and quickly restore from backup. Or we can improve availability by standing up multiple dedicated servers, creating a high availability setup either in Proxmox, or in terms of Postgres, we could use streaming replication and set up a high availability Postgres cluster. But this is one of the benefits to the cloud and the platform as a service vendors, which we kind of touched on earlier. By having so much virtualization, they can just seamlessly shift workloads around. That said, it's not like the cloud has perfect uptime either. Just a few weeks ago, Google Cloud had a major outage for several hours that actually resulted in some downtime on some pretty well-known platforms. So just looking at this picture, we can see Spotify went down, Discord went down, AWS even suffered some outages, Cloudflare, Etsy, YouTube, OpenAI, some pretty massive platforms had downtime. So it happens to the best of them, and it doesn't only happen at Google. AWS has had downtime, and even besides the major outages, there's still really no guarantees on some of the minor services. I've known people who've had their EC2 virtual machines disappear, either due to hardware failures or other failures. So regardless, you always need to be thinking about availability and planning for downtime. But that said, I think the cloud providers probably have better uptime than a dedicated server on a lot of providers. I don't have any numbers for that, but looking at the SLA that OVH provides, I think it's like 99.95 or something, which isn't that great probably compared to some of the cloud services. But then again, I don't know if OVH kind of hits that SLA or if that's a kind of a poor estimate. I'm not quite sure, but so far I haven't had any issues. So with all that said, if I've convinced you to try out a dedicated server, let's move on, and I'm going to show you OVH's page here on choosing a dedicated server. So if we look at the OVH dedicated server page, they have them broken out into different tiers here. There's the Rise tier, Advanced, Scale, High Grade, and Game. They're somewhat broken out into different use cases. It kind of gives a little blurb about each one, like the game servers are optimized for video games and streaming. High Grade is the most powerful servers, and you can kind of get a sense of the pricing tier here for some of these. The one that I went with is the Rise 3, and the reason I wanted that is I wanted a higher core count and thread count, and I wanted more storage. If you click into these, also, you get to do a little bit of customization. So I believe the one I chose is I upgraded the RAM to 128. I upgraded to approximately 2 terabyte drives, and I guess they've increased their pricing a little bit because I believe I'm paying $180 per month. And then what you get over here is you choose a location, And on this page, if it says available, that basically means that if I were to buy this, I get access to the server almost immediately. But I have seen configurations where it'll say like 48-hour wait time. So I think that's just going to be waiting on them to actually rack it in the data center and actually make it available to you. But when I purchased it, it was available to me almost instantly. Oh, here's the discount right here. I must have committed to a year, so I got the $180.50. Anyway, so this is my configuration I chose. And in the next step, I will show you what the dashboard looks like after you buy your server. So after you've purchased your server and gotten an email from OVH that it's ready, you should be able to log into your OVH cloud dashboard. And if you click on Bare Metal Cloud, you should see a list of your servers here, and you'll see the dedicated server that you bought. This is the one that I bought. And you will see the type of server that you bought. You'll see the CPU under the general information, the data center, the zone, actually the rack and the server ID where it's physically located, presumably. If you bought a commitment, you'll see that down here as well. And importantly, you'll see the public IPv4 address and IPv6 as well. And by default, you should have some type of intervention enabled when you buy the server. We will actually want to go and disable that right now because we are going to be installing a new operating system. And we do not want OVH to get paged when our server goes down for that. And your RAM's over here, your data disks, and it's going to say there's currently no operating system installed. So that will be our next step. And that will be installing Proxmox, which is going to be our hypervisor. And the purpose of the hypervisor is basically to be the thin OS that sits right on top of the bare metal and is what is going to spin up our virtual machines that we're going to be installing and manage those and manage the resources for those. Proxmox also supports Linux containers. I don't really use it for that, but if you run containers, they will run in the same kernel space as the Proxmox node itself. I tend to prefer just running VMs on Proxmox, so I don't really do that, but it's an option as well. So what we're going to want to download is you click on the Downloads tab on Proxmox, and we are going to want the Proxmox VE ISO. So we'll just click and download that. Oh, and one other thing here to note, OVH does have the ability to install different OSs from template, one of which is Proxmox. It has them grouped by different types here. It starts off with the basic one, so if you wanted to just install a regular OS like a Linux Debian or Fedora or Ubuntu server, you could install that as the single OS for the entire server if you wanted to. Or they have other options here as well. They have bring your own images, and they also have, well, actually bring your own image is probably worth talking about because you would think that would be bring your own ISO, but it's not actually bringing an ISO. It's actually specifically for cloud-ready images, which means that it's not an ISO. It has to be a QCOW2 or RAW, and basically a cloud-ready image is a specific flavor of Linux that responds to sort of a pre-formatted bit of text or JSON or YAML that basically pre-installs a SSH key and does other types of basic customizations on first boot. It sets a host name, things like that. We are actually going to be later on using that to install our Ubuntu VMs, but getting a little bit ahead of ourselves right now talking about that. But that is the bring your own image thing you can install. Other options, cPanel or Plesk, we don't want that. And then under here, they do have a Proxmox template available. They also have Windows hypervisor options available. But the problem here is that for Proxmox, so I have 2 disks here. I have 2 NVMe disks. They're both about 2 terabytes or so. And I want to install those as a mirror VDEV, similar to a RAID 1. I want to install it as a ZFS mirror VDEV, but the OVH Cloud template does not really support that. They do have the ability to customize the partition configuration, which I've attempted to do. They let you change the file system to ZFS on this stuff, but I want the entire disk to be ZFS, the entire disk, not just the var lib vz stuff. So I've tried like deleting partitions. I've tried just making the root partition be ZFS and going through all this stuff. But I've never really found a setup that works. It doesn't quite let me partition it the way I want to. So basically what I end up having to do is I have to get the Proxmox ISO and install it myself. And to do that, we will navigate to the IPMI, IPMI/KVM side of things. And we are going to be using this remote KVM portion here. And it gives you two options. There's one that you can do straight from your web browser. It'll show you basically a video of exactly what you would see if you plugged a monitor directly into your server. That's what a KVM does, and lets you basically have a virtual keyboard where it's almost as if you're plugged directly into the server and typing commands into it directly. The other option is a Java applet, which is actually the option that we need because it's the only option that supports mounting an ISO on a virtual CD-ROM drive. So that is what we're going to need. And before we click that, you're going to want to make sure that you have Java Open Web Start installed. Well, you also need Java installed, obviously, but you'll need Open Web Start installed because we need that to run JNLP files, which is what this option is going to create when we click that. So make sure you install Open Web Start and have Java installed. Just follow the downloads path here for whatever you got. And then I'm going to go back and click the From a Java Applet option. And it's going to take a little bit here. But it's going to generate a .jnlp file. You see that went to my downloads directory. So and then in order to run that Java applet, I'm going to go to my downloads folder in a terminal. Let me zoom in here a little bit. Okay, and then I do Java WS, I think. And then this is going to connect to my server here, give me a direct console connection. And like I said, if we were to plug in directly into the server's display, this is what it would look like right now. This is just a Debian rescue boot, which basically doesn't do very much at all. It's just a rescue console. So what we're going to want to do is click on that little CD-ROM button up there. This little red one right up there, if you can see that. And then we are going to, this little window is going to pop up. We're going to click Browse, and we're going to go to Downloads, or wherever you downloaded your .iso. Going to open that. Going to click Connect, and it's going to say, do you want to redirect it in Media Boost mode? Say yeah to that. And once it's connected, we can close this little window. And then we should be able to go up to, there's a hotkeys thing here. And basically the way we're going to reboot it from here is mimicking hitting Control-Alt-Delete. So if we click this hotkey, it's going to send Control-Alt-Delete. And it's going to reboot. You can see the little blinking cursor up there. I'm just going to full screen this window again. And then as this is rebooting, it's going to be just like if we were at a typical computer where we're going to want to get to the BIOS to change the boot order to use our CD-ROM drive. So I'm just going to be hitting the F2 button once this starts coming up. Actually, I'm just going to start tapping it right now because there is kind of a delay between what we're seeing here and actually what's getting sent to the server itself. So I'm just going to tap F2. Tap, tap, tap. Okay, that got us into the BIOS. And then just going to use the arrow keys on my keyboard, my physical keyboard that's plugged in. Arrow over to boot. If you've ever done anything with computers, you know what we're doing here. We want to look for the CD-ROM drive, which I'm not seeing. Oh, here it is. I don't know why I wasn't seeing that. I guess I'm blind. It's boot option number 7. So I'm going to hold down Shift on my keyboard and hit the plus button to move it up. And go back up here and move it up. And I'm just going to keep moving it up until we get up to boot option number 1. Okay, now we can see we've moved it up to boot option number 1. I'm going to press F10 to save and exit, just like any other computer BIOS. Hit yes. Okay, it's finally rebooting. And server reboots are a little slower than you think. At least in my home lab, when you reboot a server, a lot of times they will run like a memory check on boot up when they start up. So that adds to the boot time. The other thing here is that this is going to be a little bit slow because of us mounting this virtual disk to our local machine. I'm on cable internet, so I only have 32 megabits upload speed. I've experienced very slow installation times here at this step and doing this part. The first time I ran it, it was actually fairly quick. It only took about 20 minutes to install Proxmox. The next time I tried it, it was like half an hour. And the last time I did it took a full hour, so you just have to be patient at this step. You are going to see some error messages here that are superfluous. You can just ignore those. It is going to boot up with our Proxmox disk. We just have to be a little bit patient here. Okay, and then when it boots up, we're going to be greeted with the splash screen for the Proxmox installer. You might think we would need the graphical option because I was showing a screenshot earlier where we saw a bunch of options in a graphical environment, but that's actually a web environment. So we're going to actually go down to Terminal UI. So hit the arrow key on your keyboard and then wait a little bit because it's going to be slow. Once you get the right option highlighted, mine took like almost 10 seconds. Hit enter. And it's going to say it's loading the console installer. And like I said, this part is going to be slow, so you just have to be patient. This Proxmox installation is going to be the most annoying part of the whole process here. But also, if you don't want the ZFS, if you're not as particular about the installation like I am with the ZFS partitioning, you can just use the OVH template, and that will go a lot faster than this. But I did want to show this as an option in case you wanted to follow along with how I do it. Or if you ever, for whatever reason, wanted to install with your own ISO, this is how you do it. I have heard people say that to speed up this process, you can basically use like a host. You can run this on a host that's physically closer to the data center where you are doing this KVM stuff from, and that will greatly speed up the process. Like I guess people just spin up like a virtual machine somewhere that's physically proximate to the server that they're installing this on. Haven't tried that myself, but that's what I've seen people mention to do on forums. Alright, eventually the console installer is going to load up, and the first screen you're going to see is the end user license agreement. So obviously just hit I agree. And then the very next screen is where we can select our partitioning setup. So for me, I'm going to go to advanced options, and I'm going to use ZFS, and I'm going to choose RAID 1, even though technically ZFS doesn't do quote-unquote RAID 1. It's a mirror VDEV. That's basically what it's going to set this up as. And it's going to choose my 2 hard disks. And all the rest of the advanced options look fine. These are all ZFS options. Those are all good defaults. So I'm going to hit OK to that. And then I'm going to arrow over to next. And I am in the Central Chicago time zone. I'm going to choose that. Next. Now I'm going to choose a root password. This is going to be the root password for the admin account. So choose a root password. choose an email. I'm going to type in my email. Next. Okay, for this part, we need to have a fully qualified domain name. So for this part, I always choose Proxmox, and then I do dash, and I do 10 random hex characters. So I have a built-in, I have a command called randhex that I kind of wrote. Which I can just show the source of here. If you want to copy this, it just uses OpenSSL. So I do a random 10-digit hex suffix. So I'm just going to do that. Oh, actually, because I'm doing this Java applet, I can't paste, so I'm just going to manually type that. 72AB50D7FE. And actually later on, I also have a command called rand alpha, which I'm going to be using later. Same idea, but instead of outputting random hexadecimal characters, this rand alpha command outputs random alphanumeric characters. Defaults to 32 long, but I can do, 5, whatever I need to do. So if you want to copy these functions, these terminal functions, to follow along with some other steps later on, go ahead. Anyway, this needs to be a fully qualified domain name, so it's got to be .arclight.run is my domain that I'm going to be running everything off of. It grabbed the public IP address from OVH just fine. I believe that's the OVH DNS server. That's fine for now. I'm going to click next. Double check all the settings look good. That all looks good to me, so I'm going to click install. Oops, I must have accidentally double pressed that. Okay. And now this part is going to take a long time, at least on my machine, it takes a long time. Because again of the virtual hard disk being mounted and going over my residential internet, it's kind of slow. So I'm just going to pause the video now and fast forward it once it's complete. This could take quite a while. Okay, well that took a full hour to install basically, but it completed and now Proxmox, or the server, is rebooting. And actually while it's rebooting, I can go up and I can disconnect the CD-ROM ISO. And actually the other thing we're going to want to do is we're going to want to go to our OVH dashboard here. We're going to want to go back to the general information. And we're going to want to get rid of this rescue boot. We're going to want to change it to boot from the hard disk. So when we initiate an OVH reboot, it's not using our rescue mode disk anymore. It's just going to check the hard disk. And also we can re-enable interventions. It's going to give me a choice here. Proactive intervention means that if ping tests failed, it's going to page OVH to come and take a look at it. I'm going to do without proactive intervention for now. You can choose the active intervention if you want. Like I said before, the server boot up takes a little bit when you reboot, but it is starting up now. We're getting the BIOS splash. Okay, that's the Proxmox boot selection thing. It auto boots into Proxmox if you don't make a selection there. And then this just looks like a typical Linux boot up text screen. And then when it's fully booted up, we can see that it's basically just telling us to connect over HTTP to the web UI. So we can do that. There's the IP address. which is my public IP address. And actually, the next thing I'm going to do here is I am going to make a DNS address for this using the host name that I chose. So I use Cloudflare for my DNS. If you use something else, you'll want to use a different. You'll want to log into, oops, I got it backwards here. You want to log into whoever you use. So my host name is Proxmox-72AB50D7FE. And there's my IPv4 address. I'm going to turn off the Cloudflare proxy. Going to save that. So now I can use my hostname.arclight.run to access my server. So actually now, let me see if it resolves already. That's an old DNS address. Proxmox-72AB50D7FE.arclight.run. And then it's port 8006. It's not the default port 80. Okay, that DNS hasn't finished resolving yet, so I can just connect using the IP address also. I'm just going to copy the IP for now. So if I connect to the IP address directly, it's going to try an HTTPS connection, and it's going to give me a warning because the certificate isn't valid, which is okay. That's expected. So going to click continue, and then we're going to use our root. Username is going to be root, and it's going to be the root password that we chose during setup. Okay, and then it's going to pop up with this little nag. It's just saying I don't have a valid subscription. Proxmox is free, but they nag you if you don't have a subscription. We can just ignore that for now. We are going to fix that later. But this here, if you've never seen Proxmox before, I can just briefly describe what's going on. This is the main interface. Under Data Center on the left-hand side here is kind of like general settings that apply to all of the Proxmox nodes that you have. For us, this is the only Proxmox node we have, but you can have multiple Proxmox servers installed, and you can create like Proxmox clusters. And if you had multiple Proxmox servers, you would have a whole list of them here. So you could set up high availability type stuff where you could be running multiple copies of VMs across different Proxmox nodes. And if a Proxmox server went down, it would fail over to a different one. But we just have the one server. So on the data center settings, you typically won't be going in here for stuff. One of the settings actually we could change right now is the storage. We are set up for, there's different areas of Proxmox that stores ISOs and container templates and snippets and stuff, and then it wants to store like disk images and containers separately. But I like to enable all the different content for this one. So I'm just going to select the local storage here, click edit, and then I'm going to select all of these and click OK. And typically we're going to be going into the node settings directly. So if you click on the name of your Proxmox box, if you click on summary, it's going to show you all your hardware resources and how they're being used. In the shell here, if you click on shell, you're actually going to get a root shell. It's going to drop you to directly on the machine. Sorry, I've got a new keyboard, so I'm constantly butterfingering stuff. But yeah, that's just a root shell. If you click on network, it's going to show you your network bridges and everything. The next thing actually, let's see, first thing we could do is we can change the DNS server. I'm going to change this so it's not using the OVH DNS server. I'm going to use Google, which is 8.8.8.8, and Cloudflare's is 1.1.1.1. We could also add the other, I think the other Google one is 8.8.4.4 if I remember right, but I'm just going to use these two for now. So change that. The other thing I would like to do is create a certificate so that we are not getting certificate errors. Let me retry the hostname connection, Proxmox 72ab50d7fe.arclight.run. Let's see if this works yet. Okay, so the domain name is resolving now. So I'm not going to connect through the IP address directly anymore. I'm going to use the host name going forward. And it's going to re-ask me for the password because the cookie is not going to follow us to the hostname connection. So next, we're going to get a valid certificate for this. So you're going to click on your Proxmox node. You're going to click on certificates. And first click on add Acme account. And it just needs your email. So I'm root@arclight.run. Accept the Let's Encrypt terms of service. That's going to register an account with Let's Encrypt. It says task OK, so we can close that. And then we're going to add a domain here. Click add. It pre-fills the host name or the name of the Proxmox node here, and I'm just going to add .arclight.run because that's my domain name. Whatever domain name you're choosing is what you're going to do here, and it's an HTTP type challenge we're going to be doing, so leave that. Click create, and then click order certificates now, and it is going to try to do the handshake with Let's Encrypt to verify that we own this domain name through the HTTP validation method. Says all of domains validated, orders ready, finalized and everything. So at the end of this, we're going to have a valid TLS certificate for our domain. Task OK, so that all worked okay. PV proxy will be reloaded. So yeah, this is, the browser's probably going to say not secure for a bit. It kind of caches this stuff, but it does say now certificate's valid down here. It says it was just issued right now by Let's Encrypt, so that's all good. The next time I restart the browser, this not secure warning should go away. And then the next thing we're going to do is there is a Proxmox VE post install script that we can run. And this just applies a bunch of common community chosen settings, one of which is getting rid of that nag screen that we saw with the subscription stuff. So I'm going to copy that. If I go back to my Proxmox server, click on the node name, click on shell. And we're just going to paste in this bash command. If you want, you can download the script separately. Just wget this .sh file and you can read through it, but I'm a trusting person. I'm just going to straight up run it. It's going to ask if we want to start the script. Say yes. And it's going to correct these sources, which we want. Yes. And we're going to disable PV Enterprise because we don't have a license. And we're going to use the no subscription repository because we don't have a subscription. And pretty much all these defaults are good. Yes, enable PV test. And yes, disable the nag message. That is important. And we can also disable high availability. Like I said, if you had another Proxmox node here, they would be talking to each other. Presumably there'd be some type of heartbeat process where if the primary went down, the other one would take over. But that is consuming a small amount of resources. And since we just have the one Proxmox server, we can disable that. So we click yes to that, and then this is going to take just a little bit to run. We can also disable that and update Proxmox VE. And it says patience here because that step, I believe the update does take just a little bit to run. All right, so once that completes, it's going to ask us to reboot Proxmox, so we can say yeah to that. And the connection is closed to the server until this reboots. So if we click refresh here, it's going to say connection refused because the server's down. So we're just going to have to wait for that to come back up. Okay, eventually hitting refresh, the server will come back up. And while I was waiting, I actually just restarted Chrome, and that made the warning about the certificate go away. The next step that we're going to be doing is we're going to be preloading the Ubuntu ISOs. Well, technically not ISOs, but the cloud-ready Ubuntu images that we're going to be using to spin up our virtual machines with. And the one that we're going to be downloading is the Noble Server Cloud Image AMD64.img, which is, like I said, not an ISO, but a QCOW2 image. And if you want to read more about what these are, Proxmox has a nice little page about it. Talks about Cloud Init's a de facto multi-distribution package that handles early initialization of a virtual machine. You can configure network devices, SSH keys, etc. Basically, the first time the virtual machine boots up, it configures all that stuff. So yeah, so we're going to download that file. So I'm just going to copy that link. And Proxmox, under this local setting, they have a nice little UI for downloading ISO images, but that actually is not what we're going to want to download. I think technically Proxmox kind of errors out if you try to use this with the .img file. So we're actually just going to click on the name of the Proxmox node. We're going to go to shell, and we're going to cd to, let me check my notes here, cd/var/lib/vz/images. And we're going to wget our URL here. This one right here. Actually, I think, come to think of it, I think the error comes when I try to use this. When I try to use this image and it's in that path, Proxmox errors out in a weird way. So I know this works for sure, so we're going to do it this way. And then to verify the MD5 sum, if we go back here, copy that. If we go echo, paste in that sum, and then paste in the name of the file. Pipe that to MD5 sum -- check. That should check it for us. It says okay, so that downloaded okay. So that's all good. One last thing we're going to do here. I'm going to close the Java applet. We don't need that anymore. So close that window. Going to full screen my terminal here. And the next thing we're going to do is SSH copy ID, because for this next portion of what we're going to be doing with connecting to Proxmox, we're going to be doing some things through the terminal. So we are going to want to be able to SSH to it rather than do everything through the web UI. So I'm going to copy an SSH key to the server. And it's going to be root at my server. Yes. Now it's going to ask me for my root password. Enter this in. So now if I SSH root at my server, it should let me in. So yeah, so now I can access the Proxmox node through terminal SSH rather than having to come to the web UI and click on the shell over here and deal with the clunkiness of using a web UI for that. All right, so at this point, I'm going to exit out of the SSH connection, and I am going to check out this Ansible cookbook that I wrote that has a bunch of Ansible stuff. I guess we could talk about Ansible a bit. Let me just clone this code. You should follow along and clone it as well. I'm just going to go to TMP. And I'm going to open this up in Cursor so we could look at it here. Yeah, so this is a Ansible cookbook. And basically what this is going to do, it's got, so Ansible, I guess, is for provisioning resources, servers particularly, it's pretty good at. So basically you put a bunch of instructions for provisioning your server in Python, actually in YAML files, but this is all based on Python. And you define in an inventory file, you define a list of servers that you want to create or modify. and the playbooks run, or Ansible runs these playbooks against it, which are a list of steps that you want the changes to be done to the servers. This very first playbook adds a NAT bridge to the Proxmox node, because by default with our Proxmox setup right now, if we look at our local network, we have this VMBR0 bridge right now. If we spun up a bunch of VMs and we tried to have them all use this, it's not going to work. They're not going to be able to connect to the wider internet because there's no NAT or anything like that, and they can't all use the same IP address. So we need to create a different bridge that has network address translation and DHCP and all that stuff. So rather than manually creating one here and walking you through that, I basically have it all programmatically put in here. It uses the bridge 0 as the external interface, and it sets up NAT and DHCP. So it installs DNS mask for the DHCP stuff, I believe. So that runs on Proxmox. And then there's a step that creates virtual machines. And it's going to use variables. There's a folder here called group vars. And there's a list of variables called VMs. And that has a list of different virtual machines that we're going to want to create. And for what I've written, I have an example that creates a Postgres one, a Redis one, and then 3 K3s nodes. And K3s is a Kubernetes cluster. It's a lightweight distribution of Kubernetes. So the idea is that I'm going to demonstrate how to run kind of a whole stack here for like web servers or stuff like that. And you can see that we can specify the IP address of each virtual machine, and we can specify the number of cores or virtual CPUs that each one gets, the amount of memory, the disk size. We can also change the username and password of the user that gets created when the virtual machine is set up. So I have different specifications for each one. Postgres is the beefiest one out of all of them, 512 gigs of storage, 48 gigs of RAM, 6 cores, and some of the other ones get a lot less than that. And then we can see here is this is the main playbook that we're going to be running called provision.yaml. It's going to try to connect to Proxmox. It checks all the connectivity statuses. It runs the NAT bridge against the Proxmox host. If we look at each playbook here at the very top, it's going to be scoped to hosts right here. It says hosts Proxmox. And if we look back at our inventory, the inventory file is where it sets that filtering. This Proxmox right here filters all these subnodes. So there could be multiple Proxmox nodes here that all filter on this Proxmox tag. You can see down here for the Kubernetes one, we have multiple Kubernetes or K3s nodes. So if we had a K3s target, it would apply to all these sub-hosts down here. So that add NAT bridge applies to Proxmox. And then if we go back to the main provision playbook, it runs that one. It waits for it creates the VMs next. So if we look at that one, that runs on Proxmox because the action to create a virtual machine needs to run against Proxmox. So it's going to iterate over that list of VMs that we had. Right down here where it says loop VMs. This is a variable that's defined in this YAML file right here. It's going to loop over those, and it's going to create each VM. And then in order to create the cloud-ready initialization file that we talked about before, there's something called a template. Ansible basically has something called Jinja, which is a template file. Here's an example of this is the DNS mask settings, I believe. So each one of these double brace things, it basically fills in variables here and then outputs a filled in text file. I guess this one is actually an inline template, but it's the same idea. This is a cloud config style text file, and it's going to output it to on the Proxmox node. It's going to save it for each virtual machine. It's going to save it in a file tagged with the ID of the virtual machine. It's going to save it on var lib vz snippets user data name of the virtual machine. And then this file is going to get bound to each virtual machine. And when the virtual machine starts up, the Cloud Ready thing is going to look at this text file, and it is going to basically initialize the virtual machine using this file. So it's going to set the host name to whatever we pick. It's going to set the username. It's going to add the user to the sudoers list. It's going to set a SSH key. And then the very last thing it's going to do is going to install Tailscale, and it's going to bring it up with our authorization key. So actually, we should probably talk about Tailscale. You'll want to set up a Tailscale account. And Tailscale is a way to set up a virtual private network. So the objective with what we're doing is we're going to have all of our virtual machines connected to this virtual private network, and our developer PC, which I've already authenticated on my side, is going to also belong to this network, so that we can SSH from my developer machine directly into the virtual machines that we're bringing up. And the reason we're doing that is because if we didn't, we would have to somehow make SSH be publicly exposed so that we could connect through the greater internet to connect to our virtual machines. So instead of doing that, instead of messing with firewall rules and worrying about anybody on the planet being able to SSH into our boxes, we just stick them on a private virtual private network using Tailscale, and that lets us connect directly to them that way without having to mess with firewalls. So you'll want to create an account with Tailscale. I will say, I'll just show the sign up page here. The only downside is they don't use email as an authentication method. You have to use a Google email account or GitHub or one of these special authentication flow type ones. And it's kind of annoying because each account that you have just gets one Tailscale network. So it would be nice if I could, and they call them tailnets, by the way. But yeah, it'd be nice if I could have multiple different ones, because this would be nice to have for development purposes, this specific Tailscale network, and I would like to have different ones for, I do backups of my ZFS stuff using a service called zfs.rent. That's a different tailnet, and I have to have like one account I'm authenticated with my Google email, another one I'm authenticated with GitHub. It would be nice if they would just have email signups where you could do like the plus addressing thing, where it would be like, root +1 at arclight.run, root +2, so we could have multiple accounts easily that way. Or if they would just let us have multiple tailnets per account would be nice too. But anyway, that's kind of a pain. But yeah, before we go further, make sure that you sign up at tailscale.com and go through the setup instructions where it's going to tell you how to authenticate with your developer PC. So I can just show that I'm signed in on my Tailscale PC right now. Tailscale status shows me connected here. Yeah, you'll want this to all be working for the next step. Okay, and just I guess we can look at the README also. We've kind of been bouncing around a little bit here. I apologize for that, but I guess I can finish explaining the rest of the playbooks. But after it creates the virtual machines, there's a playbook for setting up Postgres, and it applies to the Postgres hosts, which is just the one host that we have in our inventory. It installs the Postgres PPA, the official PPA. It installs through using apt. It installs all these repositories. It starts Postgres, configures Postgres. It's modifying the postgresql.conf file using config options that we set. And if you want to customize those, you just go under group vars, under Postgres here. There's a bunch of configuration variables. I have tuned all these specifically to the amount of hardware resources that I have. So You might want to change those. You could also change the port and the version. And then I also have this configured to use pgBackRest, which is a backup solution which backs up our Postgres database to S3. And then there's a setup Redis function, which obviously sets up Redis, the same style thing, applies to the Redis hosts. And then we have another setup for the K3s cluster stuff. So all pretty straightforward. All the heavy lifting here is done by Ansible. We just have to fill in some variables. So the other set of variables we should talk about is the vault, which this is where you're going to put all the secret variables that you don't want anybody to be able to look at. Most of this other stuff, the Postgres configuration, is really not that big of a deal to have exposed. So yeah, but anything that's private that you don't want people to see, you'll want to put in here. So we have our Postgres password is going to be in here. Our Redis password is going to be in here. And if you see in the Postgres config, I presume there's there's no password here, but if you look in the Redis one, Redis ACL password is looking at our vault password, which comes from right here. And the vault needs to be encrypted. Right now it's plain text stuff, but we can actually encrypt it and we can store it encrypted in our Git repository, so we can check it in and everything, and it's going to be just an encrypted blob. So I guess the next step here, we can kind of walk through the setup. We can run the initialization script. That's basically just going to install Python, not Python, but UV. UV is a newer Python package manager. It creates a virtual environment that kind of sequesters all the Python packages that we need into there. It installs a couple Ansible collections that we're going to be using. Does all that automatically, and then we need to activate the Python virtual environment with that. And then, like I was just talking about, we're going to run this command to generate a Ansible vault password, basically, and we're going to encrypt our vault file with that password. So we could start doing that right now. I'm going to open up my terminal again. And I guess I need to cd into the code that we had cloned. If I run the initialize, so that made sure that UV is installed. I already have UV installed, so it just installed the packages. Now I need to source.vnv bin activate, and now it's activated that Python virtual environment. And now all the Ansible stuff is going to be ready to use. And the next step we're looking at here in the README, this is basically equivalent to the rand alpha function that I showed earlier. This just generates a 32 character random alphanumeric password, and then it saves it in this .ansible vault pass file in my home directory. So that's an example of what that looks like. I could output it to my Ansible vault pass, and then we need to change mod the permissions on that to 600. .ansible vault pass, and then this command will actually do the encryption. So if we run this, it says encryption successful. It just took the 32 character password that we had stored here and encrypted that file. So now if I look at a git diff of the file, you're going to see it deleted all this stuff and encrypted it. So yeah, if I look at that file, that's just what it looks like now. So going forward, to edit that file, we need to use this command, Ansible vault edit, and that is going to dynamically decrypt the file, open it in Vim for editing, and then it is going to, after we save it, it's going to re-encrypt it transparently. So for the next step, we need to go through and edit all of these values. So we can do that now. For this one, for Proxmox credentials, actually, we are going to need to generate a token. So we could do that next. We need to do that through the web UI. Yep, so if we go in here, we go to Data Center. If we go to API tokens, we're going to add one. You can leave that root at PAM. And I'm just going to name this Ansible because that's what's going to be using this token. I'm going to click Add. It says, please record the API token secret, only be displayed for now. So we need to copy the secret value. So I copied that. And then if we go over here, I'm going to go over to my secret. And I'm going to quote it and put it right there. And the token ID should be Ansible. And the username, I believe, is root at PAM. I guess this doesn't really need to be quoted. Root at PAM. Okay. For the vault SSH public key, there's a little trick we could do. I'm going to use my public key from GitHub. So I think it's rbang. If you curl github.com/your GitHub username.keys, that will grab your public key from GitHub. Guess I should probably quote that. Okay, and then the Tailscale auth key, we're going to go into our, oh, you know what? There's one other thing I forgot to do before we go on. This just creates basically a blank API token. We need to change the permissions. If we click show permissions, it doesn't have anything. So we need to go up here and click on permissions and click add. Go down to API token permission. We're going to do just a slash and then choose our token right there. And then we're going to choose administrator privileges because we need full privileges. Okay. So now our token has full permissions. And then for Tailscale, we're going to go over to Tailscale settings. Go to keys. I actually have old keys here. I'm going to delete this stuff. Okay, you're going to see something that looks more like this, where it's going to say you don't have any auth keys. We're going to generate an auth key. I'm just going to name it Ansible because that's what's going to be using it. And then importantly, we need to check reusable because by default, the first time the auth key is used, it invalidates it. But we're going to be reusing this key. And it's going to be valid for only 90 days. That's the max amount of time, which should be enough time for us. Click generate, and it's going to say, just like our Ansible one, here's the secret. Copy it now because it's not going to be shown again. So copy it. And we're going to paste it right there. And then for Tailscale domain, we are going to go over to DNS and then copy this domain right here. And that is our Tailscale domain. So basically every time we create a machine, like if we look in our inventory, we create this Proxmox-01, it's going to get a DNS address, proxmox-01.tail blah 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 .ts.net. And anybody in the same Tailscale network can access it over that DNS address. And then for a Postgres password, this is just a password that we choose. So I'm going to do this little trick again where I'm going to do my rand alpha 32. And that's going to generate a random 32 character password. I'm going to actually go down to the Redis section and do the same thing. Okay, and then the last setting we need to fill in is for pgBackRest, we need a S3 bucket, S3 key, and secret. So this is a little more convoluted, but I have a doc in the Ansible repo here called pgBackRest setup. And this has basically, if you have the AWS CLI, you can follow along and just you can run these commands to create all this stuff, to create the bucket and all the permissions we're going to need. Okay. So I copied that. I'm going to run this command. I'm going to name my bucket. I'm going to name it arclight pg backup. And crap, what is my suffix? I'm going to use my hex suffix if I can remember what it is. Oh, over here. I guess I can look over here. Okay, I'm going to do that. This should create the bucket. Okay, that worked. Then just following along in the README here. Oops, wrong file. Under the docs. Okay, that creates the bucket. Then we need to create an IAM user. I'm just going to name mine very creatively. I'm going to name it the bucket-user. Next step, we need to create a S3 policy. I'm just going to copy this bucket over here. Paste it right here. So create a file s3-bucket.json. We paste that in. That's the bucket policy we need. So we need to attach that policy to the username that we just created. So I guess I should show where I got that from. Right here. So the bucket I'm using is this. I'm just going to copy my bucket name over. The username is this. Oh, I named the file S3 bucket, my bad. S3 bucket to S3-policy. Okay, let's rerun that command. All right. And then last thing, we need to create the AWS IAM access key for that user. And the username is this. All right, and here is the access key ID and the secret that we need. So I'm going to copy, there's the access key. And here is the, oops, here is the secret. And then the bucket name. What did we do for the bucket name? This one, right? Okay, there's the bucket name, and that should be everything we need here. This one up here is commented out the Proxmox API password. We're not using username and password, we're using API token, so we can actually just delete that line. And that should be everything we need in this vault file. I think there's some other values we need to fill in if I remember right. Yeah, the Proxmox node under the VMs vars, we need to fill that in. And I believe that's just the name of our node. So it's not the full domain name, but just Proxmox dash. It's basically this green check mark thing over here, that part. So I'm going to put that right there. And then the other one is our inventory file. The Ansible host is going to be the full host name. So this is going to be .arclight.run, the full DNS host name. Same thing with this, same fully qualified domain name. And I think we just need to, for these ones, we're going to be using our Tailscale Tailscale network names. So if we go back over here to DNS, copy this. So this is going to be postgres-01.this. And this is basically because Ansible, when it's running, it needs to know how to connect to each one of these for running the playbooks. So there is a little bit of repetition here where we are just kind of like repeating node name dot Ansible Tailscale network, but there might be a smarter way to do this. I'm not sure, but this is what I came up with for now. Pull requests accepted if you come up with a better solution. I think that's all we really need. I'm just thinking if there's anything else I really need to talk about. So there's also an ansible.cfg file. This just sets some defaults. I have it set up to reuse SSH connections for performance. You can set defaults for doing sudo stuff, and you can set the default vault password file, so it's not asking you where the vault password location is. For the most part, that's all we need to talk about right now. So we can run the main provision file now, and hopefully if we did everything right, it's just going to work. Fingers crossed. So yeah, if we run ansible-playbook and we do provision.yaml, let's give it a go, see what happens. So it's adding the NAT bridge to Proxmox. So actually, if I quickly jump back over to Proxmox, if we refresh this page, we should see VMBR1 just got created. I have some debug stuff here. You might want to take that out. This is spitting out sensitive information right now. I think when I was troubleshooting stuff, I left this in here, but probably want to take this out if somebody's standing behind you when you're running this stuff. It's spitting out API token secrets for Proxmox and whatnot. But it's going through creating the virtual machines. It's creating those cloud init files. And basically every time that you see Proxmox running stuff, if it says okay, it's basically saying like no changes or nothing necessary to report. If you see yellow, that means it changed something and noticed that the state needed to be changed, so it ran the state change operation. And it's worth pointing out that Ansible is stateless. Was I saying Proxmox before? Ansible is stateless, so every time you run a playbook, it's gonna connect to the remote resource, and it's gonna determine if that state is currently in a state that needs to be changed or not. This is a bit different from something like Terraform. If you use Terraform, Terraform has a local .tf state file if you're running it locally and just using your hard drive. I think there's things that store state in a shared location if you're running as part of a team or something. But anyway, Terraform saves a state, and it's relying on that. It's relying on the saved state to determine if it needs to make any changes to stuff, which can get annoying because I've run into scenarios where somehow the remote state gets out of sync with like your saved state, and you end up having to modify or prune your local state or force a remote update. So I am not a huge fan of Terraform per se. It is nice. It's got a nice lightweight syntax for like creating resources, like creating virtual machines, creating S3 buckets and stuff. It's pretty nice for, but I find when you get into the deeply imperative stuff, like here with Ansible, where we're creating the VMs and we're like telling it to like for Postgres, we're saying install these packages, make sure it's started, make sure it's updated, change this config file stuff. I find Ansible to be the better solution for that, but you can also mix and match. You could have Terraform create a bunch of blank resources. It could create the S3 bucket that we did. It could It could like create the blank VMs and stuff without doing all the imperative modifications. Like you could definitely mix and match stuff. But yeah, so it's going through. It is looks like it got past the create the VM stuff. It there's a step here that I didn't have it pulled up at, but the last step is it waits for each VM to connect to Tailscale. So if we actually jump back over to Tailscale over here, if we click on machines, we're going to see there's a bunch of new machines available in our Tailscale network. So that means from my PC right here, I can connect to any of these now. And that is how we are doing the provisioning of these virtual machines right now. Ansible is making an SSH connection to the Postgres box, and it's running all these like apt install steps. Oops, it's doing that through SSH, so it needs that Tailscale step to be completed. It needs each machine to be on Tailscale. So it finished setting up Postgres and pgBackRest. It's set up Redis, currently setting up Redis. Configuring the Redis ACL file, which has our password in it. Does a Pong test with Redis to make sure Redis got set up right. Then at the end it restarts it because there was config changes. Now it's setting up the K3S nodes. Just a side note with the K3S stuff, I kind of like Kubernetes. I know a lot of people think it's like overkill and stuff, but I've never really found that to be true. Like, yeah, you do have to learn some abstractions. You do have to learn like what a pod is, what a deployment is, ingress, all that stuff. But I find the abstractions to be worthwhile. Like they actually make sense. Like the reason that they're there. It's kind of like just learning Git, just understanding what a rebase is, what a merge is, and how it all works. It's just helpful in the long run. I'm not a big fan of like Cabal, or used to be called MRSK, I think. I mean, I looked at it when they first came out with it, and it was so bare bones. It was just basically a way to create a virtual machine and like run a Docker container and expose some ports. And I feel like, I mean, I guess I haven't given it a fair try, so maybe I shouldn't be bashing it too heavily, but it seems like Kamal now, they just keep adding more stuff to the point where it's just like a worse version of Kubernetes. Like Kubernetes has all the stuff that you need already. It has the zero downtime deployments. It has secrets, auto scaling. You could run background jobs. You can run one-off commands for database migrations. You can do different types of deployments like rolling deployments, blue-green deployments, canary deployments. But yeah, I think the main pain point in Kubernetes has always been managing the cluster, and you can kind of just sidestep that by using a lightweight distro like a K3S or a Minikube or something like that. So for me, I just roll with K3S, and so far so good. Anyway, maybe someday I'll do a video comparing Kamal and Kubernetes, because maybe I'm missing something. Anyway, so that's all up now. So we could try SSHing right now. The user that gets installed in all these VMs by default, if you look at the create VM step, it defaults to a user called Ubuntu. You can change it with that CI username, I think, CI user variable. Yeah, CI user variable. You could change it if you want to. You could also set a password. But yeah, this should be using our SSH key right now. So if I just SSH Ubuntu at Postgres-01 dot, what the heck is our tailnet? Oh, go under DNS, copy this, tailnet name. Oh, this is, I'm getting a warning because I had recreated this machine. for this demo. I've done all these steps before, so this was a pre-existing. Whoops, don't want to do that. This was a pre-existing thing I was doing. Ubuntu at Postgres-01. Good Lord. I'm trying to reuse my history and it's not liking it. Okay, SSH Ubuntu at Postgres-01.tailnet. Okay, there we go. Trust it, yes. Okay. PGLS clusters. Postgres is running, obviously. We could also do PSQL. And if we just use that tailnet name, the host name that we just used. Oh, actually, we haven't created any databases yet, so we can't do this part yet. I mean, I guess we could connect to the template database or something, but actually, there's a couple things I could demonstrate here. One is that the provision playbook is idempotent, so I just fat-fingered that a little bit ago, but if I rerun the Ansible provision playbook, I can just rerun this as many times as I want to. And it's just going to skip over stuff. It's going to notice stuff's already installed, so it's not going to do anything. It is going to be a little bit slow, like I mentioned, because it's rechecking state on everything. I guess there are some tasks that are going to show that it's changed, but it's not really changing. This task is the one that creates the cloud init data files on the Proxmox node. We could actually look at those if we pull up that playbook. I could demonstrate what that's doing. So that's var libvz snippets on the Proxmox node. If we pull that up quick, so we pull up a shell on the Proxmox node, go to var libvz snippets. You'll see that it creates a YAML file for each one of our virtual machines over here. And if we look at the Postgres one, user data 100.yaml, you're going to see it filled in everything. It filled in SSH key with the one we chose. It's filled in this instruction to fill in the Etsy hostname file with this content, those permissions. This is a little minor blip. You probably don't need this, but if you log in with a login terminal on something like a Postgres box as a Postgres user, which is also a server's account that's running Postgres, and then you log out, the Linux machine will clean up IPC files, inter-process communication files, and that can actually kind of mess up your Postgres stuff. So I usually just disable this by default. But yeah, you can kind of see how these user data things look. And this is just a file that on first boot, once again, it's just going to look here when that virtual machine first spins up. Anyway, I'm jumping around a lot, but we reran that provision playbook, and it basically didn't change anything. Like I said, there's a couple tasks that technically show changed, but they're not really changing anything. They're mostly like it's rewriting config files or like re-backing up a config file, which we could probably fix this with a little better coding to not change or not show changed. But yeah, and actually, if I deleted one of these, like if I deleted the Redis VM right now, which we could just do because whatever, we're not really using it yet. I just click stop over here, and that's going to force it to stop. And then if I go to remove, I have to type the name of the VM. That's going to fully delete that VM. So that's just gone now. That VM's permanently gone from Proxmox. Now if I rerun my provisioning playbook, it's going to notice, actually one quick thing while that's running, I got to jump over to the Tailscale side of things, and I have to delete the Tailscale machine for that one because Tailscale doesn't know that we just deleted the Proxmox virtual machine. Anyway, it's going to notice that the right here, notice that the Redis virtual machine's missing. It's going to notice that showing up on certain steps right here, I guess it is. and it's just going to recreate it with all the same things we did before. It's going to use the same IP address, 10.0.0.110, etc. And it's hung at this step because it's waiting for the it's waiting to be able to SSH to the Redis box using the Tailscale magic DNS. And we can see that succeeded now. It took just a little bit for that VM to do its first boot stuff and connect to Tailscale, but we saw it just reappear here as well under the Tailscale dashboard. It just appeared at the bottom there. And so it's going to rerun through the rest of the playbook and check the state and everything. The other thing to mention is we're running this provision playbook directly right now, and this playbook kind of delegates to all these other sub playbooks that we have that I put under this provision directory here. We could also run these playbooks here individually as well. So if we just wanted to, I guess we would have to run the create VMs one first. That would create the Redis. It would create the Redis VM, and then we could rerun this one, and that would skip over waiting through all the Postgres steps and whatnot. But no big deal. It's just going to run through and check the state and everything, realize nothing's changed, and do nothing basically at this point. For Postgres anyway, it's going to reset up Redis now. While that's finishing up, I'm going to show the one other playbook that we're going to run. If we look at the README file here, I think it explains it, but there is a provision playbook that we just ran, and that does the provisioning, that sets up the actual hardware resources. And then I have a separate playbook for setting up application databases. So this step is going to create a Postgres database called myprojectdb with a owner called AppUser. It's going to enable some extensions, and it's going to create the AppUser Postgres user with these permissions. And the other thing it's going to do is it's going to generate a local file using the Jinja templating system that we were talking about earlier. That's going to output Kubernetes manifests so that we can connect to Kubernetes, create Kubernetes services basically that can connect to these databases. Okay, so that did a bunch of changes here on the Proxmox and Redis side to recreate the Redis VM and configure it. So now instead of running provision, let's run the application YAML, and that's going to create the Postgres database like we just talked about. I'm going to delete this S3 policy JSON. We don't need that anymore. All right, so did that. Another file that gets created somewhere in here is it creates this file called k3s.yaml, and this contains the permissions that we need, the secret or whatever, to connect to that Kubernetes cluster that we created. So we're going to do this command. We're going to export kubeconfig equal to that file, k3s.yaml. So it's set to that file. Now if we do kubectl cluster info, it's going to say that it's successfully connected to the Kubernetes control plane at our master. Core DNS and metric server all running there. Can run kubectl get nodes. I guess I should have specified earlier, if you don't have kubectl installed, you'll need that installed as well for doing Kubernetes stuff. You can just Google kubectl install, I'm sure, and figure it out. And then also in our repo here, we have some example files. There's an nginx hello world. This is going to run a Kubernetes service that basically just runs this nginx demos hello world Docker image. Just a real basic hello world, spins up nginx without connecting to anything at all. It's just a standalone nginx instance for just doing basic testing, so we can run that. So I'm going to do kubectl apply -f, and if you're not familiar with Kubernetes, it's very heavy on the YAML for all these specifications for running stuff. Okay, so that should have created some pods. But more importantly, it created some services, or I mean a service, excuse me. And it created it at this port right now. So if we do we could do a curl key3s master 01 dot. Keep forgetting this tailnet address. If we do it at this port, that is going to show our the output of the hello world. Actually, let's just do it in the browser. That's going to be a lot more readable. So there, it's running an nginx hello world, and we're connecting to it over Tailscale. So this is only going to be visible if you are connected to the Tailscale network. Somebody, just some rando out on the internet, if they type this in, they're not going to be able to see this. This is private over our Tailscale network. And so that's the nginx demo. We can also run this db test app YAML file. And this is going to, if we look at this YAML specifications, for Kubernetes, each one of these triple dashes is kind of a separate Kubernetes resource that it's creating. So right here, it's creating a config map that's setting some non-sensitive config variables. It's basically specifying our Postgres IP address and the port, and it's saying connect to this database and then connect to this Redis host and this Redis port. And then in the sensitive side of things, instead of doing a config map, we're doing a secret, and it's storing it under this not namespace, but this key name thing, setting our app user of our Postgres database and our app user Redis thing, Redis password. This is all being populated using a template over here. If you look at this template under db test app, I have it set up so it's just interpolating all this stuff from our vault basically, and outputting it to this local file, so we can easily refer to this local file when we do the kubectl apply. But basically, it's just a Python standalone one-liner Python web app that's just basically proving that we can connect to Postgres and Redis from the Kubernetes cluster. And if you notice, we are not connecting over the tail network from the Kubernetes cluster. The Kubernetes nodes can all connect over the Proxmox VMBR1 bridge right here, and that is more efficient than going over Tailscale because we don't need to do all the encryption and the rest of it. So this is a direct connection, bridge to bridge connection, very, very efficient. So we can do kubectl apply, and instead of doing the nginx example, we're going to do db test app. Now if you do kubectl get service again, now in addition to the hello world service, we also have the db test service, and it's running on this port. So if I copy that and then go back here and we change the port number to this new port number, this is going to show that successfully connected to the Postgres database. This is basically just it's doing like a test select and cluster info type commands on Redis and Postgres, proving that we can connect to it. So yeah, so that's good. And that pretty much demonstrates how we can spin up Kubernetes resources. And then the last thing I want to demonstrate is using Cloudflare Tunnels. For this last step, you're going to need to have Cloudflare D installed, which is a Cloudflare CLI command for modifying Cloudflare tunnels. Actually, I have a pre-existing tunnel from messing with this before. I'm going to need to delete. Okay. That one's okay. All right. So Cloudflare Tunnels is basically a way of exposing a web app or other type of application to Cloudflare. So instead of Cloudflare calling your web app over a publicly accessible route and then proxying based on that, it kind of flips it around where your web app connects to Cloudflare using this tunnel service and basically exposes a private route to Cloudflare that way. So it makes it a lot simpler because we don't need to publicly expose anything, and we don't need to add a bunch of rules like disallowing access to just some random Joe who finds the secret route to your web app that only Cloudflare is supposed to be proxying over and stuff. So it's a nice way to connect to Cloudflare, and it's a nice way to like provide a public DNS address to a web service that way. So more or less what this is going to end up doing is it's going to, first of all, we're going to create these Kubernetes resources in our cluster. It's going to create a namespace called Cloudflare Tunnels. Inside this namespace, it's going to have some config stuff that's going to say, for different routes, it's going to say expose these routes over these, expose these different local services over these public domain name host names. And it's basically going to run a Cloudflare Docker image, Cloudflare/Cloudflare D. And that is going to be, it's going to be the little like binary thing that's running, that's routing all this traffic. Sounds more complicated than it really is, I guess, but and this is all going to be running within a separate namespace in Kubernetes. So when we're doing kubectl git pods and stuff, it's not going to be showing all the tunnel stuff. Anyway, I wrote a script that basically automates a lot of this stuff. So we can just run this script /setup Cloudflare tunnel. Oops, I forgot to give it a tunnel name. I'm going to give it the tunnel name db test app, I guess. And then the script is basically going to say what domain do you want to use for this? What domain do you want to expose your Kubernetes service over? I'm going to choose dbtestapp.arclight.run. And just to prove that's not currently doing anything, we can go dbtestapp.arclight.run. It says there's nx domain, non-existent domain. So that domain does not exist right now. I just goofed up my terminal doing that, but db-testapp.arclight.run. It's going to authenticate with Cloudflare, which I already am. It creates a Cloudflare tunnel resource with this ID. It creates a CNAME record up here, which routes to that tunnel. And then like we talked about, it creates the Kubernetes resources in the Cloudflare Tunnels namespace. It skips monitoring because we're not running Prometheus on our Kubernetes cluster. Then at the end, it says, okay, you can test your application right here. So we just copy that URL, which we were just testing. Guess it doesn't look any different, but because I'm refreshing over the top of our Tailscale connection, but this is publicly exposing this this service over the internet now using the arclight.run domain suffix. So that's pretty freaking easy. And then if we also wanted to add more services, if we want to expose more stuff, we could do like say we wanted to expose our Hello World app that currently isn't exposed. There's instructions here in the README for doing that as well. It's actually under the docs Cloudflare tunnel. All we have to do basically is we need to edit the config. Well, first we have to manually create a tunnel, I guess. Which is going to say for this given Cloudflare tunnel, that tunnel routes this DNS address. So we need to copy the tunnel ID that was created earlier. And if you closed your terminal or whatever, you can just type Cloudflare D tunnel list, and you'll see it right here. So we need to do, what was the command? Cloudflare D tunnel route DNS, and then the tunnel ID, and then whatever domain name we want to do. So I think I said hello world-app.arclight.run. So that creates the CNAME hello world app.arclight.run, and it says it's going to route that tunnel for that route. So if we go back and refresh over here, it's not giving us non-existent domain anymore. It's saying HTTP 404, because if we look at the config map that Cloudflare is currently operating under, that's the default rule. So if we copy this little command here, kubectl edit, this is basically a way to edit a Kubernetes resource. It'll pop open a built-in Vim editor or whatever to edit it. And so this is what that resource currently looks like. And like I just said, the catch-all rule here is a 404. And we basically just need to comment this out, because this example comment is kind of already set up for what we're trying to do. But I just need to change the domain name, because we are going to route hello-world-app.arclight.run. And the service name is correct. It is hello-world-service, which is what is the name of our current nginx service, which we can see by doing kubectl get service. Right there, it's called hello-world-service. If it was called hello-kitty-service or something, we'd have to change the config map to use that service name right here. But yeah, with that change, I think we just have to restart the Cloudflare tunnel pods to see that change. Yep, we can do a rolling restart, which will just restart those one at a time. I think we have to restart. Yeah, it's not seeing the change till we do that restart. So do this kubectl rollout restart, and that is going to do a rolling restart of the tunnel pods. And then if we refresh, now we can see that we could see the nginx service exposed publicly over that that DNS or that domain name. So pretty cool. So yeah, that's basically the whole video. We showed how to provision a OVH server from scratch, how to mount a Proxmox ISO, install Proxmox, and use Ansible to spin up a bunch of virtual machines, configure the virtual machines, connect to Kubernetes, spin up an example Kubernetes application, and then finally we exposed it publicly using Cloudflare Tunnels. So hopefully you found that helpful. This is how I'm kind of running my side project applications right now, my side project web applications. And yeah, let me know what you think. I got more videos on the way. Thanks for watching.